Hello everyone, welcome to the solution of LeetCode problem 946 named Validate Stack Sequence. In this problem, we are given two integer arrays, pushed and popped, each with distinct values, and we have to return true if this could have been the result of a sequence of push and pop operation on a initially empty stack, or we have to return false otherwise. In the first example, the pushed array contains 5 elements, which is 1, 2, 3, 4, and 5. And the popped element, which also has 5 elements, which is 4, 5, 3, 2, and 1. Now, we might do the following sequence here. If we push the first 4 elements in the stack, then our stack will contain 1, 2, 3, and 4. Now, if we pop the element 4 from the stack, so this 4 is validated. Again, if we push the element 5 into the stack contains 1, 2, 3, and 5. Now, if we remove all of these elements, 5, 3, 2, and 1, this 5, this 3, this 2, and this 1 will be removed from the stack. So we can say that these two of the sequence form the valid stack push and pop operations. But in the second example, it is not possible for these two pushed and the pop operations to validate the same sequence. So in this case, we have to return false. I hope you understood the problem statement. Now the array length can be in between 1 to 1000, and each of the array element can be in between 0 to 1000. And all of the elements of pushed are unique, and the length of the pushed array and the popped array is equal, and popped is the permutation of the pushed array. Anyways, the problem statement might seem little bit of difficult right now. I will explain it in the next section. Now let's move on to the algorithm section. Now here, to understand the algorithm, we have taken the first example. The pushed array has 5 elements, which is 1, 2, 3, 4, and 5. And the pop array has 5 elements, which is 4, 5, 3, 2, and 1. Now we have to take a stack so we can validate whether these are the valid pushed and pop sequence or not. So now let's try to dry run the examples first. Here in the pushed case, we have 5 elements, which is 1, 2, 3, 4, and 5. So here at first we have to push element 1 in the stack. Then we can push element 2 in the stack. Then we can push element 3 in the stack. Then we can push element 4 in the stack. Now here in the popped, the first element is 4. That means we can pop the element 4 at first. So here we have to remove this element 4 from top of the stack. Now we have to erase this element 4. So again here we can push the element 5. So here 5 will be pushed. Now here we can see that in the pop sequence, the rest of the element are 5, 3, 2, and 1. So here for this element 5, we can remove this element 5 here. For this element 3, we can remove this element 3 here. For this element 2, we can remove this element 2 here. And for this element 1, we can remove this element 1 here. Now we can say that after performing all of the pushed and the pop operation, the stack become empty. So in this case, we have to return true. But otherwise, if we cannot make the stack empty, then we have to return false. Now, it is the brief explanation of the problem. Now let's see how can we solve this problem by using the stack data structure. So here, as we are given two arrays, which is push and pop, we have to iterate all of the element of the pushed array from left to right. And for pop sequence, we have to take one pointer here, which will indicate the possible popped element. Suppose the pointer name is j. Now, if we iterate each of the element in the pushed array, our first element will be 1. So here we have to insert one element or the element 1 into the stack. Now we have to check whether this element 1 is equal to the pointer value of the popped array. So the pointer value of the popped array is 4. So we can say that 4 is not equal to 1. So we don't have to anything do here. Now for this element 2, again we have to insert it into the stack. And we have to check whether this element 2 is equal to the current pointer value j. So here we can see that this 2 is not equal to the 4. So we don't have to do anything here. Now our current pointer is pointing to third element, which is 3. So we have to insert the element 3 into the stack. But this element 3 is not equal to the element 4 here. So we don't have to do anything here again. Now our current pointer is pointing to element 4. So we have to push the element 4 into the stack. Now wait, this element 4 is exactly equal to the pop sequence element, which is 4. So here we can simply remove the element 4. So if we remove the element 4 will be popped from the stack. And after removing the element 4, we have to upgrade our j pointer. So our j pointer will currently point to this element 5. Now we are at this element 5. So we have to push the element 5 here. Now we have to check whether the top element of the stack is equal to the j pointer value or not. So you can see that the top element of the stack is 5, which is equal to the j pointer value 5. So we have to remove the top element from the stack and upgrade our j pointer. So our j is pointing to this element 3. Now again we have to check whether the top element of the stack is equal to the current j pointer or not. So here we can see that the top element of the stack is 3 and the j pointer value is 3. So we have to remove the top element from the stack and we have to upgrade our j pointer. Now our j is pointing to the element 2. Again, we have seen that this element 2 is exactly equal to the top element of the stack. So here again, we have to remove the top element 2 from the stack and we have to upgrade our j pointer. So j is pointing to the last element 1, which is exactly equal to the top element of the stack, which is 1. So again, we have to remove this top element of the stack and upgrade our j pointer. Now, our current j is pointing to the out of bound values. So now we have completed iteration of all of the element of this pushed sequence and this pop sequence. Now we have to check whether our current stack is empty or not. So here we are clearly noticing that our current stack is completely empty. So in this case, we have to return true. But unfortunately, in some of the cases, if we perform this algorithm, the stack will contain some of the value after finishing the iteration. So here in those kind of cases, we have to simply return false. I hope you understood the algorithm. Now let's move on to the code. Now here we are given a function named validate stack sequence, which has two lists, which is the pushed array and the pop array. Now here we are using one stack and one j pointer, and we are iterating all of the elements from left to right of the pushed array. At first, we are inserting the current element into the stack of this push array, and by using while loop, we have to check whether the top element of the stack is equal to the current pop pointer value. If it is, that means we have to simply remove the top element from the stack and update our j pointer. After that, after completing this iteration, we have to check whether the stack is empty or not. If our stack is empty, we have to return true. Otherwise, we have to return false. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate all of the element of the pushed and the pop array. And the space complexity is also big O of n because we are taking extra memory stack to solve this problem. And in the worst case, the size of the stack can be equal to the size of the input array. So we can say that the space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.